All right, hi everybody. In this lab you're going to explore conservation of energy by analyzing a pendulum. So what's a pendulum? Okay, a pendulum is really nothing more than a mass that hangs from a string. This is a useful trick when you're trying to hang a picture straight in college and you don't happen to have a level. Okay, we know gravity only pulls straight down, so what we have here is a perfectly vertical line. If we set the pendulum or the plumb bob into oscillation, well, now it becomes a pendulum. All right, in the lab, you're going to make some predictions and observations. You also need to make some measurements. All right, the lab is divided up into two sections. There's two pendulums set up, one that has this brass mass, and the other that has this number 3 fishing weight. This will be the cut short pendulum, okay, because the lab is divided into two parts. So when you make your measurements, all right, you want your measurements to be to the center of mass of the pendulum. That's its balance point. The pendulums have these number 3s stamped on there, so that's approximately where the center of mass is for your pendulum, but you want to check to be sure. So what you want to do is when you get out to the lab table, is just try to take the pendulum and balance it on your finger, and that's its balance point. That's its center of mass, and for me it's pretty much right at the top of the number 3. That's the way I'm going to make my measurements. Okay, the next thing that you need to do is you need to pick a start height for your pendulum. Okay, and you're going to want to record this value. The numerical value isn't so important as long as you stay consistent. All right, you don't want to release the pendulum from too high, okay, to where it's falling and the string comes loose before it starts swinging, and you don't want to go too low either. So somewhere a nice middle angle is good. You're going to make your measurements relative to the table height. Okay, so pick a nice round number. Okay, so I picked here, and you know what? I think I'm going to put that here because it puts it right at 60 centimeters. Okay, and for every trial for the cut short, this is where you want to release from. So once you pick this, you want to stick with this, okay? You're going to be making some predictions about releasing the pendulum and making predictions about where it's going to swing. So the pendulum is going to swing down through its path, and then it's going to swing over here. Now, your predictions are going to be based upon observation. And when you release the pendulum, you want to know, is it going to swing lower than the height that you release it, equal to, or above, okay? And so you're going to want to test this several times and come to a consensus with your teams before you make a decision, all right? Once that's done, you're going to introduce this second crossbar so that when you release your pendulum from your start height, and again, that needs to be the same every time, okay, that the swing path of the pendulum is literally cut short by this crossbar. All right? The first thing you're going to do is set your crossbar equal to the height to which you release the pendulum, which for me was about 60 centimeters. Okay? And that's the height from which you're going to release your pendulum. And again, it's about making predictions and then making observations. So when the pendulum hits the crossbar, our options are swinging to somewhere lower than the crossbar, swinging equal to the height of the crossbar, or swinging higher than the height of the crossbar. Okay, and of course we know that we're in lab, so we expect some error. So when we're talking about equal to the height of the crossbar, anywhere in here, we call that about equal to. If it's either lower than the crossbar or higher than the crossbar, it will be obvious to you. Okay, and then you're going to move this pendulum, or you're going to move this crossbar up and down, and you're going to repeat prediction, observation. Okay. Later in the lab, all right, you're going to find the point to where you can lower this crossbar to where your pendulum is going to loop around it. So, like, you're going to find that spot there. All right. The lab asks you to measure the height of the loop. And what that means is when the pendulum comes in and comes around, at its highest point, which would be the very top of its loop, how high is it above the table? And again, we want to measure to the center of mass. So you would make your measurement here, and for me it's somewhere around 55, 56 centimeters, okay? And you're going to compare that to your drop height, all right? And from there you'll be able to do some analysis in terms of conservation of energy. That completes the first portion of this pre-lab. We'll pick it up over on the other side of the table with conservation of energy.
All right, so here we are with part 2 of the lab. The purpose of this lab is to determine if the pendulum is set into motion and allowed to pass through a photogate. So what you're essentially going to be doing is 3 trials of this, 3 unique trials, and for each trial, what you're going to do is you're going to pick a height from which you're going to drop your pendulum. And the first thing you're going to need to do is determine the total energy of the pendulum at this point. So we can clearly see at this point, before you drop it, the pendulum is not moving, so that should help you determine your kinetic energy. And it is above the table at some height, so we do need to measure the height to determine our potential energy at this point. When you do this, please make sure you measure the height from the table to the center of mass of the pendulum, which is roughly in the center of this cylinder itself. What you'll do then is you're going to let it go. As you let it go, please make sure that you are in fact aligning the pendulum itself with the Photogate. You want it to move through the Photogate. This pendulum does have some mass to it, and it's going to be moving with some significant velocity when it gets down here. With that much momentum, if it does strike the Photogate, it can do some pretty big damage, and these are pretty expensive. So we want to make sure that we do in fact line up our pendulum with our Photogate, and it does pass through without striking the Photogate. Please be careful there. Now, as you let go, we can see that energy, that potential energy, is converted to kinetic energy and begins to move through the Photogate. Once our pendulum has reached this point, it is above the table still, so at this point it is still going to have some potential energy. So we do need to also measure the height above the table when our pendulum is at our lowest point. Again, make sure you measure from the center of mass of this pendulum when you're doing this. In addition to having potential energy, of course, the pendulum is going to be moving pretty quick through the Photogate, and that's the purpose of the Photogate, to determine the velocity of our pendulum.
Okay, so how is it that we're going to determine the kinetic energy of the pendulum? Well, what the Photogate does is the Photogate uses an infrared light. There's two sensors, or there's an emitter and a detector. Okay, here's the light, excuse me, and here's the sensor. What the Photogate does is all it does is record time values. So when you start the Photogate, that's arbitrary. It's not going to give you any data until it's blocked. All right. So what you're going to do in the lab is by allowing the Photogate to swing, or the pendulum to swing through the Photogate, you're going to get two times. The first time that will be recorded on the computer screen will be when the Photogate is blocked, and then the second time will be when the Photogate can see the detector again. And it's going to be the difference of those two numbers that's going to allow you to calculate how long the pendulum swings through the Photogate. And when you do this, you're going to get some very small numbers. All right, the pendulum has a fixed diameter. It's not going to get any bigger or any smaller. It's 2.8 centimeters. So what we have here is a known distance that moves through a point in space in a time that you're going to measure. If we have a known distance and a calculated time, that's how you're going to record velocity, and the mass is printed right on the top of the pendulum.
So what we'll do from there is we simply want to make sure that we're comparing the total energy at this point before dropping to the total energy here where it's slightly above the table and also moving right here at the bottom. Your job will be to perform this 3 separate times based on your 3 unique drop heights, and then you're going to do some analysis to determine if energy was in fact conserved. Theoretically, we know that energy is conserved, and we should have an energy up here that is equivalent to the total energy down here. Things you want to make sure you're also doing, besides obviously taking care of that Photogate, is that when you do allow the pendulum to pass through the Photogate, what's going to happen is that, of course, pendulums, by their very nature, oscillate. They go back and forth. Your pendulum is going to make a return trip through the Photogate. Okay? If it does that and moves through the Photogate will continue to keep collecting data. It will close and open again, and every time it passes through, it will continue to close and open. Okay, for our purposes, when you reference your data on the LoggerPro software, you only want to use the first closing and opening pieces of information to calculate the velocity of our pendulum. Any subsequent passes through, we can go ahead and ignore. Other than that, please make sure that you do answer the web-assigned questions and that you read the lab carefully, and of course ask your teacher if you have any further questions about the lab. Good luck.